Right, let's start Unit 40, the factor affecting the chemical equilibrium. So in the previous case, we have done a lot of exercise like this, right? But please keep in mind that, as I always mention, this is extremely important sentence, is the value of Kc is dependent on temperature only. That means if there is no change in temperature, there will be no change in the value of Kc. So this is very, very important. So what about the topic in this unit? So what we are going to discuss is what will happen if we change the external environment will bring any change to the equilibrium. And here we got a quick revision. Still remember last time at the end of Unit 39, I have come across a question is there is extra HI is added to the system and the result is QC is greater than KC. Still remember this one? So the conclusion is there are too much product now. We need to have a net backward reaction. Well, good. This is changed the equilibrium position already because I need net backward reaction. Okay, so how can we interpret or how can we express our answer in the public exam is, alright, so first of all, there is no change in value of Kc because the temperature is unchanged. But because there is extra Hi, so the system is no longer in equilibrium because Qc not equals to Kc anymore. So in order to keep the new equilibrium and keep the Kc constant, so the H2 and I2 must, what should I say, increase because we have too much product, right? While the Hi must be decreased. A net backward reaction. Alright, let's highlight this sentence, net backward reaction. In scientists or in chemistry, we have a special term for that. It's called equilibrium shift to left. Net backward reaction means equilibrium position shift to left. Alright, so this is a new interpretation. You will come across a lot in this unit. Alright, so how can we interpret this? Okay, now it's not so clear. At certain time, the Hi is added. So net backward reaction means the Hi will drop. And again, the H2 or I2 will increase. Alright, so please keep in mind that both of them become horizontal. Okay, means no change anymore. Or new equilibrium is established. Okay, but this concept is easy, right? Okay, they will achieve a new equilibrium, but be careful. The new equilibrium for Hi is greater than the original one. Okay, this one will be greater than O1, and the same case is for H2 and I2. They will be a little bit greater than the original one. And that's it. Alright, so see what will happen or what question you will see in the public exam. Now, here we have Haber process again. Okay, equilibrium constant expression, easy. right? Okay, even I can give you the unit, right? It's no problem. Well, now an extra N2 is added. So in order to keep the new value, in order to keep the KC unchanged, okay, in order to keep the KC unchanged, now N2 is added. That means the denominator is greater. So I need to, there are too much reactant, so I should consume, I should consume extra H2 and N2 to keep KC unchanged, right? So the concentration of H2 will decrease. This is easy to understand because too much reactant. Or you may say the QC is less than KC. It's up to you. While for NH3 is extra NH3 will be formed, right? So the concentration of NH3 will increase in order to keep the value of KC constant. But this is the key point. Alright, here I introduce I would say is a general or empirical rule for the change in equilibrium position. It allows us to get the insight on whether will be net forward or net backward reaction. This is called Newtonian principle. Alright, well luckily is it seldom require student to spell his name, okay? Newtonian principle. So what Newtonian principle mention is the condition, if the condition of the system change, the system or the position of equilibrium will do everything as possible to against the change, okay? Or just as followed by the notes is reduce the change. Well, this is not so difficult to understand. So use your daily example. Okay, you use your daily life as an example. If you get more pocket money, of course you will spend more, right? Why? It's because you try to reduce, you try to against the change. In reverse, if your pocket money is less than what you expected, then you will spend less. Why? It's because you want to keep certain amount of pocket money in your pocket, right? So if you spend the same amount, then your money will run out quickly. So if you get less pocket money, you will spend less in order to reduce the change. That's it. Or in a general case, for example, let me use another example if you don't happy. In summertime, you will switch on the aircon, right? Why? It's because you want to do something to against the increase in temperature, right? Alright, in reverse, in winter, you will switch on the heater. The reason behind is simple. You want to do something to against the drop in temperature. You don't want to have any change. So this is Newtonian principle. You will do everything to against the change. You don't want to change, right? In DSE syllabus, we will have 3 categories. The first one is change in concentration. The second one is change pressure by changing volume. The third one is change temperature. So I will go through one by one. First of all is the change of concentration. Here I use this equation. This is chromate iron. This is, okay, you are familiar of that already. Dichromate iron, right? So if extra acid is added, okay, extra acid means reactant is more. Okay, reactant is more. That means QC is less than KC. Then what will happen? The color become more orange. Okay, because after adding acid, hydrogen ion concentration increase. So according to the Newtonian principle, I don't want to change, or I don't want any change. So I should do something to consume extra acid, right? System wants to consume extra acid. So what should I do is, I shift the equilibrium position to right. That is net forward reaction. Because if I produce more product, then I will consume more reactant, right? So with this idea, the dichromate concentration will increase and the chromate will decrease. So sure, the reaction mixture become more yellow. Now here I introduce a good method for you, a pictorial method for you. Okay, this is what I learned when I was a student. So here shows, focus on our equation. If extra acid is added, so I use an arrow pointing up. Oh, this is extra acid, right? So if extra acid is added, then the reactant side will be higher. Okay, will be higher. Just like imagine this is a mountain. Okay, reactant side is higher than the product side. Then here you imagine a ball will roll from high to low, right? The ball will roll to the product side. That means there is net forward reaction. Okay? So use this arrow can allow you to handle whether net forward or net backward will be followed by. So become more orange. Okay? Well, next one. So what if NaOH, sodium hydroxide, is added? Okay. Now, with the same idea, this time, if you add alkaline, then there will be neutralization, right? Neutralization. So use our arrow. This time, hydrogen ion will be consumed. That means the reactant side will be lower, right? The mountain this time is changed. The product side will be higher. Then, still remember the ball? The ball will rotate from high to low. Yes, that means this time we will move to the equilibrium side, to the left hand side. Okay, so let's finish our job. Because neutralization will consume H plus. So by Newtonian principle. Okay, don't worry, this is not necessary, okay? Okay, because you have consumed hydrogen ion. So I don't want any change, right? So please, the system produce extra hydrogen ion to compensate the loss. Extra hydrogen ion will produce to gain the change. So equilibrium position will shift to left. Okay, I highlight here part of product. Okay, so it's up to you. You no need to copy the green words. Okay, will turn back to reactant, and as a result, the reaction mixture becomes yellow because chromate ion concentration increase, right? So have a look on this. The equilibrium position shift to left and produce more chromate ion. And okay, an extra information for you. That's why we don't have alkaline dichromate solution. We have acidified potassium dichromate, right? But we don't have alkaline potassium dichromate. It's because of this one. Because in alkaline condition, the dichromate will decompose into chromate ion. Okay, so the basic principle is the position of equilibrium will shift to reduce the change of concentration. Okay, equilibrium position will shift. Okay, professional B. Okay. Alright, so here is the checkpoint. So let's see. Okay, try to use the arrow. The arrow and the ball. Okay, I think this is very easy and convenient to use. If you add some PCl5, okay, increase, then the ball will rotate this way, right? So that is net for a reaction, equilibrium position to the right. Easy, right? The system will respond by consume extra PCl5. I don't want any change, right? So what about we move PCl5? Oops, this is decreased. Then the ball will rotate or will move to the reactant side. So net backward reaction and left, right? So we'll produce extra PCl5 to compensate the loss, right? Okay, so part C and D is your turn. Okay, add some chlorine. And remove PCl3. So, right? Oh, it should be produced, not product, right? Okay, sorry. This produce. A net forward reaction and to the right. So, if you use a pictorial illustration, the ball and the mountain, they will be easy for you to handle, right? Well, highly recommend this method for you. Okay. And okay, so next one, again, please spend some time. Okay, let's do it and pause the video and let's do it. Because the equilibrium position shift to right, so extra HCl and O2 will be formed, so both of them should be increased and H2O should be decreased, right? So the answer is D. When some HI is added. So B and D surely not the answer, right? They will not keep unchanged or they will not even go higher. So A and C. So what will be the result is, yes, they will drop, but as I mentioned, they will not drop lower than before, right? So the answer is C. For question 4, A looks nice. What about B? Adding CS2? No, because I need to shift to right, right? No. We move H2S? No. Finally, we move CH4? No. So the answer is A. Right? So you can see, even for me, I always use mountain and the ball. Alright. Question 5 and okay, question 5 first. Question 6 is a bit complicated. Suddenly, the reaction rate of backward reaction increase. This is a suddenly increase. So what happened is, so I can expect there is increase in NH3, right? So the answer is easy, C. So yes, some of you may wonder, so what about if we remove N2? Yes, if you remove of N2, there will be also net backward reaction. But the difference is, now this one I should highlight. This one is backward reaction unchanged, but forward reaction drop. So net backward reaction. Okay. The difference is, this one for C is backward reaction increase, but forward, reaction unchanged. So net backward reaction. Yes, both of them, both B and C will need to net backward reaction, but their mechanism is different, right? With this one, please recall unit 36, 38, 36, and 7. Increase concentration will increase reaction rate. Still remember? And yes, that's the point. For point B, because N2 is decreased, so the forward reaction rate will drop. Okay? That's the difference. And okay, so for question 5 is really worth you to spend a few minutes to understand it. This is not so easy. So feel free to find me whenever you got any question. All right. Question 6 is complicated. Okay, it's complicated. Well, question 6 is complicated because it is asking about two knowledges. Okay, don't forget we need time to achieve equilibrium. Okay, always keep in mind time is needed to have or to achieve equilibrium. So you are given a syringe containing some gas which is pale yellow and dark brown. Okay, okay. Suddenly some NO2 is added. Okay, some NO2 is added to the system. Volume and temperature unchanged. So here is the result. The reaction first darken and then lighten. Well, this question is come from a public exam questions. So take a break. I will discuss it in a few minutes.